grade 10 learners, have a nice day. Welcome back to my channel. For today's video, I'll be discussing to you about theorems on inscribed angles. Before I go on, I want to say thank you to all my grade 10 learner subscribers, especially to the Davao City National High School learners from section Del Pilar, Magsaysay, Paterno, and Romulo. You may comment also your section so I can shout out you on my next video. Again, thank you so much to all of you. Before we go on with the theorems on inscribed angles, let us try to understand first about inscribed angle. Inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. Next, about intercepted arc. Intercepted arc is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. Okay, we have here a circle. Angle AIM is inscribed in the circle. Arc AM is what we call the intercepted arc. This one, arc AM. While angle AIM is what we call inscribed angle. Now let's begin with theorem number 1 on theorems on inscribed angle. First theorem. If an angle is inscribed in a circle, the measure of the angle equals 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. Let's have an example. In the figure on the right, angle AIM is an inscribed angle. Arc AM is the intercepted arc. Find the measure of arc AM. Okay, if we have here M, this is the measure, and the symbol here is the arc. So find the measure of arc AM if the measure of angle AIM is equal to 65 degrees, this one. So by applying theorem number 1, that the measure of the intercepted arc is twice the measure of the inscribed angle. So by solution, we have this. So our given is the measure of angle AIM, which is 65 degrees. So to get the measure of arc AM, we have to multiply the measure of angle AIM by 2. So therefore, by substitution, we have measure arc AM is equal to 2 times 65 degrees, the measure of angle AIM. By the way, where did we get this 2? We get this 2 from the theorem that the measure of the intercepted arc is twice. The word is twice the measure of the inscribed angle. That's why we have here 2. It's based from the theorem. So now we have to multiply 2 times 65 degrees. That is equal to 130 degrees. Therefore, the measure of arc AM is 130 degrees. From this point up to this point. This is the arc AM. Another example as an application for theorem number 1. Okay, we have here a circle. Arc FT is the intercepted arc of an inscribed angle, angle FAT. Okay. Find the measure of angle FAT if the measure of arc FT is equal to 56 degrees. So in here, we're going to find the measure of this angle, this one, angle FAT. So again, applying theorem number 1, we have The measure of angle FAT is equal to 1/2 the measure of the intercepted arc FT. So given is the measure of arc FT, which is 56 degrees. So by substitution, we have measure of angle FAT is 1/2 of 56 degrees. Now we'll simplify. So 1/2 times 56, or that is 56 divided by 2, that is equal to 28 degrees. Therefore, the measure of angle FAT, this angle here is 28 degrees, which is 1/2 of 56, the measure of arc FT. Next, we have theorem number 2. If two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Talking about congruent meaning they have the same measurement. In the figure at the right, we have here inscribed angles SAR. We have here two inscribed angles SAR. Okay, I will try to label this. Okay, this one SAR. Oh, so sorry, it's not a straight one. Okay, and the other one is angle SOR. Okay, SOR. So this one SOR. Okay, this one. The two angles, if you have observed, they intercept the same arc, which is arc RS. Oh no, it's not perfect. But for the emphasis, you just try to consider. So according to theorem number 2, if two angles or two inscribed angles intercept the same arc, then the two angles are congruent. So therefore, angle SAR and angle SOR have the same measurement. So if measure angle SAR is 1/2 measure of arc RS by applying theorem number 1, and measure of angle SOR is also 1/2 of measure arc SR, then measure of angle SAR is equal to the measure of angle SOR. Therefore, angle SOR, this symbol is congruent to angle SAR. This is a symbol for congruence. Okay, so therefore, if we're tasked to find the measure of the angle, just like here, we are tasked to find the measure of angle SAR and SOR. To solve this, okay, that is measure of angle SAR is 1/2 the measure of arc RS. So this one, arc RS. And since given that the measurement of arc SR or RS is 120 degrees, then 1/2 of that, 1/2 of 120 degrees, or 120 degrees divided by 2, that is equal to 60 degrees. Then it follows that the measure of angle SAR is 60 degrees. No more long solution to solve for angle SOR since they intercept the same arc. Therefore, the measure of angle SOR is also 60 degrees. Applying theorem number 2, that the two inscribed angles are congruent if they intercept the same arc. Okay? Now, let's have theorem number 3. If an inscribed angle intercepts a semicircle, then the angle is a right angle. Remember that a right angle is an angle with a measure of 90 degrees. And remember also that a semicircle is half of a circle. So if a circle is 360 degrees, in my previous video, a semicircle is 180 degrees. We have here a circle S. Again, we're going to name a circle according to its letter on the center. So since the center point is S, so this is circle S. So by symbol we have here circle S. Arc FT, this one is a semicircle and intercepted by an angle FIT. So we have here angle FIT. In other words, angle FIT has an intercepted arc of arc FT, which is a semicircle. If we're tasked to find the measure of angle FIT given this figure, how are we going to solve this? If you have observed, you are not given any data. But remember that we have here arc FT, which is a semicircle. And remember that a semicircle is 180 degrees. So by the way, how will we know that it is already a semicircle? Okay, always remember that it's half of a circle. So try to look at the diameter. If there is a diameter just like this, then you can easily locate the semicircle. So the diameter is a chord, the longest chord that passes through the center. So though you do not have any data or any number given here, we can still solve the measure of angle FIT. So arc FT is automatic that the measurement of this is 180 degrees since arc FT is a semicircle. So therefore, to get the measure of angle FIT, we have 1/2 of 180 degrees. Applying theorem number 1, that the inscribed angle is 1/2 the measure of its intercepted arc. So in here, our intercepted arc is arc FT. So the measurement of angle FIT is equal to 90 degrees. And of course, 90 degrees is a right angle. Next, circle N. This is circle N. And line segment KD is a diameter. Since it's a diameter, we can conclude that RKD is a semicircle. This one, RKD. This is a semicircle. Since it's a semicircle, then it follows that angle KID is a right angle. Okay? So angle KID is a right angle since it intercepts arc KD, which is a semicircle. Okay, let's move on with theorem number 4. Theorem number 4 states that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. What do you mean by supplementary? Supplementary angles refer to two angles whose sum is 180 degrees. Example of an angle with a measure of 100 degrees and 80 degrees, the two angles are supplementary. Another is if an angle has a measure of 60 and 120 degrees, they are also supplementary. Meaning to say, their sum is 180 degrees. So once you add 180, so we'll have 180 degrees. Also 60 and 120, still we have 180 degrees. Okay, next, we have here circle A. And a quadrilateral. When we are talking about quadrilateral, we are referring to any four-sided polygon. Okay, remember that? Any four-sided polygon. So it can be rectangle, a square, a trapezoid, a rhombus, a kite. All of those are quadrilateral. Quadrilateral PIN key is inscribed in circle A. Now let's try to determine first the pair of opposite angles. So the pairs of opposite angles are, we have here angle K and angle I. The opposite angles K to I. Another name for angle K is angle PKN. Always remember that the vertex is at the center if we're going to name an angle using 3 points. And angle I can also be named as angle PIN, but it cannot be named by angle IPN. Always remember that I should always be the center. Another pair of angles here we have angle P, and angle N. Okay. So another name for angle P is angle KPI, and another name for angle N is angle INK. Okay. So the sum of the two angles, angle P and angle N, is 180, while the sum also of angle K and angle I is also 180 degrees. Now, if measure of angle K is 60 degrees, this one, and measure of angle N is 90 degrees, find measure of angle I and measure of angle P. So to solve for measure of angle I using the fourth theorem that the sum of the opposite angles in a quadrilateral is equal to 180 degrees because they are supplementary, then we have to substitute. Angle K is already given, which is 60 degrees. So therefore, the measure of angle I is 180 transpose 60 degrees to the other side of the equation. So we have 120 degrees. So measure of angle I is 120 degrees. Once we add the two, their sum is 180 degrees. Now to solve for measure of angle P, we have given of measure angle N, which is 90 degrees. So by substitution, we have measure of angle P plus measure of angle N, which is 90 degrees, is equal to 180. So measure of angle P is equal to 180 degrees minus 90 degrees. So this positive 90 is transposed to the right side of the equation. And therefore, measure of angle P is equal to 90 degrees also. So this angle here is also 90 degrees. So once we're going to add the measurement of the two angles, their sum is 180 degrees. Another example, we have here circle S and a quadrilateral BLUE is inscribed in circle S. If the measure of arc EBL is equal to 150 degrees, arc BE is 60 degrees, and arc LU is 120 degrees. Find the measure of each angle. So meaning to say, we're going to find the measure of angle L, angle U, angle E, and angle B. But this time, given is the measure of the arc. Okay, let's begin with angle U. So to solve for angle U, since it's already given that the measure of arc EBL is 150 degrees, applying theorem number 1, then we can have measure of angle U is 1/2 the measure of arc EBL. So by substitution, we have measure of angle is 1/2 of 150 degrees. So therefore, angle U is equal to 75 degrees. Okay, next, let's solve for angle B. So if you have observed, we already solved angle U. Okay, we are going to apply the theorem number 4 that the opposite angles of a quadrilateral inscribed in a circle is supplementary. So therefore, angle B plus angle U is equal to 180 degrees. Now let's substitute. Measure of angle B plus measure of angle U, which is 75 degrees, is equal to 180 degrees. Angle B is equal to 180 degrees, 75 transpose, so it becomes negative 75 degrees. So subtract 180 minus 75 is equal to 105 degrees. So therefore, angle B is equal to 105 degrees. Next, we have to solve for angle E. So to solve for angle E, we need to have the measurement of arc BLU, but it's not given. We only have the given of arc EBL and arc LU. So we have to solve first for the measurement of arc BL. Okay, arc BL. So since given is the measure of arc EBL, which is 150 degrees, is one arc EBL, we can determine the measurement of arc BL by subtracting the measure of arc EBL by the measurement of arc BE. Okay, so given arc EBL is 150 degrees and arc BE is 60, and that is equal to 90 degrees. So therefore, the measure of arc BL is 90 degrees. So we can now solve for our angle E since we have already the measure of arc BL and arc LU. So solving for angle E, we have 1/2 of the measure of arc BLU. So we have to add the measurement of arc BL, which is 90 degrees that we have already solved a while ago, and arc LU is already given, which is 120 degrees. So 90 plus 120, that is equal to 210 degrees, and 210, half of 210 is equal to 105 degrees. Therefore, angle E is 105 degrees. Now, let's solve for angle L. So to solve for angle L, we have to apply the fourth theorem that the opposite angles are supplementary. So angle L plus measure of angle E is equal to 180 degrees. And now let's substitute. We already have the measure of angle E, which is 105 degrees. So to solve for angle L, we have 180 minus 105 degrees. Therefore, angle L is equal to 75 degrees. So once we add the opposite angles, this one, their sum is 180 degrees. And also here, their sum is 180 degrees. Thank you so much for watching, guys. Kindly like, and if you have questions regarding the video, kindly write it in the comment box. Kindly share it to other students for them to learn or master the lesson. Please don't forget to subscribe to be updated for more math lesson videos and turn on the bell for notifications. Before I end, let me share to you one of the verses from the Bible. God is a refuge and strength, a very present help in trouble. Psalms 46 verse 1. That's all for today, and God bless you all.